Hello everyone, welcome again to our machine learning career track here at Code Heroku. My name is Mihir Thakkar and I am the founder and instructor at Code Heroku. If you would like to get started with machine learning for free, we have a complete machine learning career track for you on our website, which includes several free videos, projects, assignments, and live doubt solving sessions. I'll put the link in description for you. Let's see what we are gonna study today. We'll study differences between a database system and a file system. Till now, we have been using CSV files, right? So even when we were dealing things with pandas, you were reading those CSV files, which was essentially stored in a file system. So why do we even need a database system? SQL will be used to interact with this database, but why do we need the database system in the first place? So we'll be going over that. Then we will see why do you need SQL as an important skill for a data scientist or a machine learning engineer. Running your queries on a database system versus doing something in pandas is where the concept of server side versus client side processing comes in. Is processing or running your queries on a database like MySQL, is that server side or is it client side? Whenever you run a database, it runs its own thread. Okay, so it is definitely server-side processing. Whenever you are running a database system, it is server-side processing. Even if you install your MySQL database locally on your computer, that doesn't mean that your processing is happening what we term in computing as client-side. Whereas when you are processing your queries in pandas, so now can you think, is that server-side or is that client-side? Then we'll obviously do some hands-on exercise because that's the format of every class over here at Code Heroku. We don't want to just talk about things, right? We have already done a lot of talking when we were in our engineering colleges and in our schools. Is everyone with me until here? All right. So file systems versus databases. You have studied this in your undergrad school. That is what I'm assuming, but I just wanted to give you a quick refresher, right? So that everything is fresh in your head. The first thing that you should know about file systems is that they provide abstraction to your physical file system. So when you are on Windows, when you do a copy and paste between these different file systems, do you think that it works seamlessly? Do you as a user have to do something special? Let's say if you're copying from a floppy drive, or I'm not sure if some of you have seen floppy drives as well or not, but let's say if you copy it from your hard disk to your USB device, is it seamless for the users, or does the user have to run a special program or do something special? File system is an important component within the operating system, which gives you that abstraction, which makes that possible, so that user doesn't have to deal with those hardware complexities. Okay. Whereas a database, what it does, it provides logical abstraction on top of the data. So most of the data, even a database, is built on top of a file system, right? You need some sort of abstraction layer below that. But what databases do is provide one more layer of abstraction, which is a logical abstraction on the top of the data, which makes accessing the data much more easier, and you could access the data in multiple ways. One of the problems with file systems is that multiple users can't access the same file at the same time. Have you guys in your companies use shared drives? Right, so you might have seen that as soon as someone opens it, you can't overwrite the same file. And can someone think why it might be important for a file system to have that lock over there? So some might say that it is there by design, because you want to make sure that if I change something to the file, at the same time you are not able to do that, right? To avoid inconsistency. Himanshu got that right. It could be seen as a feature as well, but it could be also seen as a limitation, that hey, I want to collaborate with other people, so what do I do now, right? But databases are designed to have multiple accesses. Let's say if you're going to Code Heroku's website and you're getting some data from that database, right? At the same time, your classmate also logs into the same website and the same page. Does the database, is it possible for the database to just serve one user, or is it necessary for the database to be able to give this access to multiple users as well. It is by design, it is required that the database should allow multiple users to access the same data, right? Even though it is at the same time, right? And how do you go about doing it? That's a different problem. So file systems are generally good for unstructured data. And whereas the database systems are really good for, now this, if this was back in 2010 or 2008, or maybe in our textbooks as well, they would say that databases are only good for structured data, right? But today what we've seen is there are a lot of people who use databases for unstructured data as well. Can some of you point out, a lot of you are software engineers, can you point out some databases which are great for unstructured data as well? So traditionally what you have seen is databases were good with structured data, and people used to use relational databases and SQL-like databases for structured data, for storing structured data. But in recent days, what we have seen is with the advent of so many new technologies, people have combined the advantages of file systems with on top of databases. So be able to query, index the data at high speed, at the same time have the flexibility of a file system wherein you could store unstructured data, something like an image or a video file. You might have heard of blob storage as well, right? Or key value pair storages. So that's all great for storing unstructured databases as well, or for storing unstructured data as well. Okay. So one problem with file systems is you need different programs to read and access different types of files. Okay. If there is a video file, you need to have something like a VLC player. If there is an image file, you need to open it using an image viewer, right? And so on. But whereas a database, what it does, it provides standard APIs to the data, right? So it could be creating the data, it could be indexing into it, it could be querying it, creating tables, but there is a well-defined API that you call to the database abstraction layer, so that it's there are no there are no things like plugins or those things that you need to install on top of a database to do the standard queries. Okay, does that make sense? So that's a good thing about databases. And here are some examples of file systems and databases. Of course, MySQL, the most popular open source SQL database which exists today. SQLite, and which is something that we'll be seeing today in our class. MongoDB for unstructured NoSQL-like databases. So here are some good features about a database management system. The first important thing is having scalability. Can you think of some other use cases where the scalability aspect is important, that you can scale or you can replicate the database horizontally across multiple servers? Yes, outages, right? So if you have enough redundancy, if one server goes down, your application as a whole doesn't fail, right? So Himanshu, thanks for pointing that out. Does anyone have anything else to add on that? Most likely, if you have like terabytes of data, it won't be possible for you to just have it on one server and in just one file system, right? I'm sure there might be some technologies which help you to do that now, because today we have a tool for every possible thing. But most likely you'll put that on a database if you have so much of data. Okay, so in terms of sheer size as well. Security. Let's say if you have multiple roles in an organization, a CEO will obviously need to have much more access to multiple aspects of that data. They might need access into different views of that data as well, right? But a new intern who just joined in, they might need to have some aspects of data that need to be revealed to them. You don't want to reveal the financials of your entire company to this new intern who just joined. It's all or nothing, right? So either you have access to the file or you don't. And you can have some access level controls of maybe who can read it or who could write it. But you can't say in a file system that there are first 3 pages that someone can read and then the next 3 pages you can't read. And atomicity. Have you heard this term atomicity before? Either all work should be completed or nothing. So let's say, no, let me give you an example. Let's say we have a database of a bank. In that bank, you want to, some person has sent the money to someone else. Do we need that transaction to be atomic in nature? So if I credit someone 100 at the same instant, I should be guaranteed that the other person will be debited 100 rupees as well. Does that transaction have to be atomic in nature? And another important feature that database systems provides us with is data integrity. If it is a database and if you have defined a column as date time, there won't be any other values than date time. You might have some missing values or null values, but other than that, you won't have any other value. You won't have a string over there. You can either write a date time to it or you can't write anything. And also multiple views into the same data. I want my Indian customers to see this in INR. So I want this in euros as well. With a database system, what you could do is you could have multiple views of the same data and you could create new columns which are presented consistently to all your users. Okay. So this is not like in pandas, you could also create a new column. Did we do this exercise when we had a column in the class? In one of our classes, we did this exercise where we had a column in, I think it was euros, and we created a new column which was in USD. As soon as you close your program, is that gone? Unless you save that back to this data frame and back to the CSV file, that column is available only to you. As a data scientist, it is available only to you and no one else who is accessing that CSV file. But with databases, you could create views to the same data which is available to multiple users. So anyone who uses that database, now they could access those views as well. Okay, does that make sense? Which of the following statements is true? Database operations are always faster than file systems. Well, that is not true always. Okay, that is not always true. For simple operations like just reading the data, if you want to read the entire table, because there are no overhead operations on it, you will always get the data faster from the CSV file. The place where database now comes in, complex queries, right? So if you want to say, give me all rows where this column is equal to another column, right? At that point, now database is optimized for those operations, right? So there are indexes, or if you want to have a sorted result back from your database, your database knows the order. It already stores it in that format. So your database operation will be much faster. Okay. So database operations are not necessarily always faster. So that is why it's a false statement. So file systems are best suitable for structured records. As we saw, this is not true again. File systems are best suitable for unstructured records, such as just a text file, video file, MP4, or something like that. Database systems allows for more flexibility in accessing the data. This is a true statement. File systems allow multiple users to access at the same time. Again, this is again a false statement. So let's go to SQL. SQL stands for Structured Query Language, and it is one of the most popular standards or ways to interact with a relational database. And again, it's not necessarily just one particular language, but it is a standard. And out of that, there have been various flavors of SQL language that exist today. And so some popular standards or implementations of SQL are these: MySQL, Oracle database. So Oracle has its own version of SQL that they use, something, I think it's called PL SQL. I'm not very familiar with that, but a lot of people use it. So something that we're going to study today, which I have not listed over here, is called a SQLite database. Okay. And the reason that we are going to use SQLite is it is a little bit easy to get started, to get a knack of the language itself. We're going to use SQLite. And again, it has its own limitations and some advantages that it has. Just so that you know, just because it is SQLite, it doesn't mean that people don't use it or it is not used in production. I think millions of companies use SQLite databases as well. Even Boeing aircraft manufacturers, they have SQL-like databases in the flight control system as well. Right? So it is not something which is not for production use. Don't think that way. So why are we studying SQL in a data science course or in machine learning? Well, because relational databases are everywhere. Okay, so all of these companies in some form of the other, they have the data in the SQL data warehouse or a production database that is using SQL Server. Okay. It is one of the most popular technologies that exist today. So I got this chart from StackOverflow Developer Survey 2019. Right. So this year, as you see, after JavaScript, HTML, SQL is the third most popular technology that people use. Right. So it is even above Python. The same thing that you could do in SQL, you could do in Pandas as well. But why are we still learning SQL? Let me just briefly tell you what will be the workflow for most data science projects. You will have a data warehouse or your production server where your data is stored. You would write SQL queries to get some part of data. If you have 1 billion rows, you can't even, it is not physically possible to get all those 1 billion rows from that data set into your main memory on your computer, right? So your Pandas data frame will crash. Take a subset of data over here, right? Let's say you take 10K rows and then you do processing on it. From server side, we'll write some SQL queries to get the data to client side, and then we'll use Pandas data frame on it to do more analytics on it. Does that make sense? So again, let me tell you what we are comparing. We are comparing processing your data in a SQL like query versus doing it in Pandas. Okay. And which one is which? Server side is SQL or is it Pandas? Server side, I'm talking about SQL. Okay. And client side, I'm talking about Pandas, like processing your data using a Pandas or a tool like Pandas, right? It could be any library. So for any complex transformation as such, no, it is not guaranteed that both of them will get the same results.